Hello and welcome back to the breadboarding tutorial series. In the previous video we discussed the voltage divider and the PT1000, and in this video we're going to be discussing the two final sensors, the Tsic and the DS18B20, or the Dallas for short. So before we begin, the Tsic and the Dallas are digital thermometers. They are slightly different to the analog one, the PT1000, in the sense that we don't need to convert the voltage reading into bits. It's already done for us using the digital components within the sensors. Secondly, the Tsic and the Dallas are very similar, but there are slight differences in them. The Tsic has a built-in what's called a pull-up resistor, but the Dallas does not. We'll discuss what this means more later in the video. So let's just cut straight to it and get into discussing the Tsic and Dallas. What we have here is the two sensors, the Tsic and the Dallas. The Tsic is a little bit more flat than the Dallas, as you can see. The Dallas is quite rounded, it's almost got a semicircle shape to it. The Tsic has a little bit more refined edges, and because it's the easier one, we're going to start with the Tsic. It's important to know which leg is which on the sensor, otherwise you might plug it in wrong and actually damage the component. This left-hand leg here, so if we look at it from the top, we have the curved edge towards the camera here. So with that facing upwards, the left-hand leg here is the 0 volt line, and the right-hand leg is the 5 volt line. This middle one is the one that we would put into our digital pins on our Arduino to be able to read what comes out of it. As I said, this has a pull-up resistor inside of it, so we don't actually need to worry about that. And what we're going to do is we're just going to simply plug this into our board into columns 1, 2, and 3. You can kind of just push the legs a little bit on these ones because they're a little bit more sturdy than the PT1000. There we go there. So now that our sensor's quite comfortably into our board, let's connect our supplies. The left leg is our 0 volt and the right leg is our 5 volt, so we'll plug in our 5 volt to column 3 and our 0 volt to column 1. And there we go there. So now that we have connected this, we can also connect our yellow wire, our data wire, so to speak, and we will take this from column 2 over to one of our digital pins. Just since it's quite close and easy to reach, I'm going to put into our digital pin number 2. So that would be the simple thing that you need to do for connecting the Tsic. When you set up your Arduino code for this, what you have to make sure to specify is which digital pin that you use. On some codes that you may get for the Tsic, it may require you to identify which pin on the board that you've used for your 5 volt input supply, or your VIN, but also on some of the libraries it doesn't actually require this at all. It's important to make sure that when you're reading your code you know which one of the codes you are using, but you will discuss this more in the Arduino series. So now that we've set up our Tsic, let's move over to the Dallas. Now that we've got the Tsic out of the way, let's have a look at our Dallas sensor. Again, the legs are very important to get the right way, so on the left we have our 0 volt, and on the right we have our 5 volt, and in the middle we have our data wire once again. Now, to get into the pull-up resistor. The pull-up resistor, what happens is you want to make sure that you don't supply too much current to the sensor. If too much current comes up this 5 volt wire, it can damage the internals of the sensor. This would also mean that we would never get good readings out of the sensor and we would have to replace our sensor. What we have to do is we have to put in a resistor that is connected between the 5 volt leg and our COM port leg. What this does is it prevents the current from getting into the sensor, damaging it, and it then jumps the voltage back up when it comes back out of our data wire. So what we will do is we will connect our 0 volt data wire and our 5 volts into our board, as we did with the Tsic. Again, you can just kind of force this into the board. Don't try and break the legs, we don't want to break them. And what we'll do is we'll connect our resistor into columns 2 and column 3. Here we go. For the Dallas, it requires a 4.7 kilo ohm resistor as the pull-up. Anything less and it can in fact damage it, and anything more is just added protection. We do not have any 4.7 kilo ohm resistors at the moment, but we have one that's very close, so it won't make a high difference. What we're going to do next is we're going to connect our 0 volt line and our 5 volt line onto our board to finish our circuit. As so. And then just to finally complete it again, we are going to add our data wire pin back into column 2, thus completing our Dallas. What you would want to do when you're creating your final circuit is have the Tsic and Dallas in parallel with each other, so they both get 5 volts. And you would also have the PT1000 in parallel with the two of these, so they also get the 5 volts. This will be covered in a later video, but for right now, that's everything that I want to say about these two sensors. So, with all of that being said, thanks for watching, and in the next video, we're going to start discussing soldering. We will discuss the safety of soldering and how to make sure you don't burn yourself when you are doing it. Thanks for watching, and bye for now.